Our next lesson is all about products and quotients. Remember, when we talk about products, we're talking about the answer to a multiplication problem. So when you think products, we should be thinking multiplication. And when we think quotients, we should be thinking division. The answer to multiplication and the answer to division. So we get this multiplicative property of 0. And this is going to seem like something that's really dumb up front, but it's like people are usually like, yeah, I totally know that. I don't even need to think about that. Why are we learning that? Because actually a lot of people waste their time doing math that they never had to do because it was very much easier. So it says for every real number a, meaning pick any real number and multiply it times 0, and the answer will be 0. Now you know this, 0 times anything will give you 0. The other one is that the multiplicative property of -1. And it just says that for any number, if you multiply by -1, you're going to get the opposite of that number. So let's say for the zeros, if I do 3 times 0, I know that answer is going to be 0. Just as if I did 0 times 7, the answer is going to be 0. If you multiply times 0, your answer is going to be 0. If all that's involved is multiplication, then definitely the answer is going to be 0. And if you are multiplying by -1 and that's all that happens, then you are going to get the opposite of whatever number. For example, 9 times -1 will give you 9. -9, the opposite of 9. If you take -457,000 and multiply by -1, you're just going to get the opposite of that. You're going to get the positive 457,000. So the idea is, it doesn't really matter what the numbers are, as long as you know what that -1 and that 0 are going to do. Now here's the part that some of you are like, you're golden on, and then some of you needed the refresher on. So here are rules for multiplication. The product, meaning when we multiply, of two positive numbers or two negative numbers is a positive number. So if I do positive times positive, I wrote those right next to each other in parentheses because that means multiplication, the answer will be positive. Just as the same as if I multiply a negative times a negative, the answer will also be positive. Negative times negative is a positive, positive times positive, positive. The product of a positive number and a negative number is always a negative. Multiply a positive and negative, you will always get a negative number. Reason being, I even had somebody come in this morning from another class and they're like, can you help me? They're like, I'm trying to multiply these two numbers, but I don't know whether it's going to end up positive or negative. You go, just multiply the numbers, and then we'll figure out whether it's positive or negative at the end just by saying one of them is positive, one is negative. The absolute value of the product of two or more numbers is the product of their absolute values. So like if we've got -3 times 5, and we take that absolute value, so the absolute value of the product of two or more numbers is the product of their absolute values. It's the same thing as 3 times 5. Those two things are the same thing. It's like making each one of them, as long as we're multiplying, it's like making each one of them positive, which would then be 15. Because even if you did this the long way, you went here, -3 times 5 is -15. If you take the absolute value of 15, that would just end up as 15. You notice it's still the same thing there. All right, so here's what we're going to do, is we're going to do some examples, and you can do this the long way if you want, but we can use some rules here. Let's go left to right and decide what's going to happen here. We've got -3 times -2. Is that going to give me a positive or negative value? Positive. And what is 3 times 2? 6. I take 6 and I multiply it times -1. What am I going to get? Remember, this will just change it to its opposite, so we get -6. Now we've got -6 times 4 times -5. We're going to keep working left to right. What is -6 times 4? Is that positive or negative? It's negative, and what number? -24. Times -5. Now, even if you don't know what 24 times 5 is, it's negative times negative. It's going to end up as what? Positive. And now it's 24 times 5. So take a minute and just calculate that. Left to right. All multiplication, that's all I did is left to right. Let's go on to another one. got negative 4 times 3. What will that give me? Negative 12. Notice I'm rewriting every time, and I'm not rewriting because I'm such a nerd that I love writing numbers so much, but it just helps me keep track of the numbers that I'm working with and what I'm doing with them. A lot of the mistakes that I saw in the quizzes were because people didn't write what they were doing, and they made a mistake along the way. So negative 12 times negative 2 gives me positive 24, and a positive 24 times a negative 1/3. Now, if you're like, I forgot how to multiply these, that's okay. We can just do 24 times negative 1/3. So we're going to multiply these. But if we're going to multiply these, it would be easier if 24 was a fraction too. How can I rewrite 24 as a fraction? Over 1. Multiplying straight across the top. So this is a positive number times a negative number. This is going to end up negative. Multiplying across the top would give me 24. And across the bottom is equal to 3. Is that done? What else can I do? Simplify, and it becomes negative 8. 3 goes into 24 8 times, and that number is negative. Now, something should stand out to you on C, that this is what I mean. This is why we learn that rule, is because this problem should take you no more than 3 seconds. Why? Just don't tell me what the answer is. Why should it take me no more than 3 seconds? Because there's a 0. And anytime you multiply it times 0, if all we're doing is multiplying, the whole thing will end up as 0. Think about it. These two multiplied together will give me some number, and then that some number times 0 will be 0, and then 0 times 13 will be 0. So ultimately this, no matter what, is going to be 0, because all we are doing is multiplying by 0. 24 times negative 15, that's a number. It's a negative number. I don't know what it is off the top of my head, but that number times 0 is 0. And 0 times 13 is 0. Yes, sir?
If we have that question on like a quiz or a test, would we have to show work either way?
No, but you could just say, if you wanted to just write 0, you could just say anything times 0 is 0. That would be enough work for me. That shows me exactly that you understand the concept. Things like that, like teachers love to give problems that look like this, and they'll make it a really long, obnoxious problem with a 0 being multiplied at the end. There might be 20 numbers to multiply, and it looks like you're going to be sitting there for hours, and then there's just multiplied times 0 at the end. And you go, oh, that's just going to be 0. Save yourself the time. Knowing that rule saves you a bunch of work on that one. All right, scrolling down. A product of non-zero numbers is positive. So non-zero means the number, you can't use 0, like any number but 0. A product of non-zero numbers is positive. So multiplying two numbers will give me a positive number if the number of negative factors is even. What they're saying is that if you have an even amount of negative numbers, the answer will end up positive. For example, negative 2 times negative 15. There's an even amount of them, a negative times a negative, that's going to give me a positive. So if I had 20 different negatives, I know the answer is going to be positive. The product is negative if the number of negative factors is odd. Notice negative 2 times negative 15 times negative 1. Now that answer is going to be negative. A negative times a negative is a positive, times another one is negative. So just count how many negatives you have, and if you have an even amount, the answer is positive. If you have an odd amount, that answer is going to be negative. And as we saw, the product is 0 if any one of the factors is 0. As long as we're not adding anything to it, like when we're talking about the product there, we're just talking about multiplying there. That answer to the multiplication part will always be 0. Now, you could add something to that at the end and it would change the final answer, but the product, the answer to the multiplication part, will still be 0. So far, so good? Today's lesson is going to go pretty quick because I'm going to hand back your quizzes and we're going to go over it today. You will have those to keep and to take home with you. All right, so next up we've got the property of the opposite of a product. So it says for all real numbers a and b, just meaning if you pick two real numbers, like not imaginary numbers, which we'll learn about later, if you pick two numbers and multiply them together, then this negative part, if we say negative ab, that negative could go with the a or it could go with the b, either way. So let's take a moment here and just look at this. I'm going to be multiplying all of these things together there, and I want to know whether the answer is going to be positive or negative. Will that one be positive or negative? Remember, I just count how many negatives I have if it's positive, because I have an even amount. So I know this answer is going to be positive. So now let's deal with the numbers. 2 times 3 times 5. What is 2 times 3? 6 times 5? 30. So our first number is 30. What happens to that x and y? Well, x is looking for other x to multiply. It doesn't have any other x's, so we just got 30x. And y is looking for another y to multiply with, and it doesn't have any, so it just becomes 30xy. Yes, sir?
Where did 30 come from?
So let's do it like this. So I'm going to go back a step. Let me do some erasing here. So what is 2 times negative 3x, Barrett?
Negative 6x.
Negative 6x, good. And negative 6x times negative 5y. So when we multiply those, is that going to be positive or negative?
It's going to be positive.
Good. And what's 6 times 5?
30.
Perfect. Now there's where our 30 came from. I just did it as 2 times 3, which was 6, and 6 times 5, which is 30. Now we've got that x and the y. X is looking for other x's to multiply with. He doesn't have anybody. Y is looking for other y's to multiply with. He doesn't have anybody. So we've just got x and y there. All right, so let's try that on B. Remember, multiplication and division has to happen before addition. There's additions here, but the multiplication has to happen first. So let's start here. What is negative p times 2q? Okay, so it's definitely negative because a negative times a positive negative. There's a 2. It doesn't have any other numbers to multiply with. There's a p. It doesn't have any other p's to multiply with. And there's a q. It doesn't have anybody else to multiply with either. P's are looking for other p's to multiply with. Q's are looking for other q's to multiply with. Plus, now we've got some other things to do over there. 3p times negative 2q, is that going to be positive or negative?
Negative.
It's a negative. P is looking for anybody else to multiply with. He doesn't have any other p's, so we've got, let me do the numbers first. 3 times 2 is 6. We already know that's negative. P has nobody else to multiply with. Q has nobody else to multiply with. Now notice what happened when we're done. Negative 2pq plus negative 6pq. Those letters are exactly the same, pq, pq. So we can add them together. I am adding a negative plus a negative. Remember, this goes back to what we did before. If I add two negatives together, what will that answer be? It's going to be positive or negative? I heard both.
Negative.
Right, so we're not multiplying here, we're adding. So negative plus negative is more negative. Now, they're both the same, they're both negative, so what do I do with that 2 and 6? I add them. 6 and 2 is 8. I have negative 8 PQ. All right, so let's try another example here. Notice here, I've got multiplication, I've got division, I've got subtraction. I'm sorry, I don't have division. I have multiplication, I have subtraction, I've got parentheses. My order of operations says I need to do this first. What can I do inside the parentheses?
Subtract 1 half.
Okay, so what is 3t minus 1 half then?
2.5t.
Can I do that?
With the 1 half of the t as well.
Why can't I do that? They're not the same. And so here's why I can't do that subtraction. So I think you guys would all agree if I said this. 3 apples minus 1 half apples You guys would be okay with that, right? You can subtract those. If I had 3 apples and I take away 1.5 apples, I know what I've got. However, these two things are not the same. I can only do that subtraction if they are the same, and I cannot do that because they're not the same. A 3t needs, if I'm going to take something away from it, they also need to be t's. So there's no other t's there to take away. How many t's should I take away? Well, those aren't t's. That's just 1/2. So what we're going to have to do here is I can't work in that parentheses. There's nothing to do in there. Like, this is the one part that gets people is they want to try to do this first. So if I can't do what's in parentheses and I don't have any exponents, what should I do next? Perfect. Let's do the distributive property. -2 times 3t gives me what? -6t. And -2 times -1/2 will give me +1. Please don't try to combine these together. Again, I'm going to get obnoxious by saying things over and over again, but why can I not combine those two things together? They're not both t's. If they were both t's, we would be okay. If that were one t, I would keep going, but it's not. It's just one. Totally different things. Just like 4 a's can't be added to 3 b's, they're not the same thing. The letters have to be the same. All right. Where am I going to start? What am I going to look at first? How about that? I'm looking at this parentheses. And 3d minus 4, what am I going to do there? What's up? Nothing. There's nothing I can do there because 3d is taking away 4. I can't take it away unless it's 4d's. You could take away other d's. There's nothing, no d's to take away. 3d minus 4, nothing I can do. So what next? Distributive property. So let's start with this. There's a 16d here. What is -5 times 3d? -15d. And then -5 times -4. And why am I wrong when I go, and I'm done?
16D and 15D are like.
Yeah, they got like terms. There they are. 16d minus 15d gives me? Perfect. So why is it that you guys told me 1d and I just wrote d there?
Same thing.
Same exact thing. We generally don't write that 1 out in front other than to illustrate that it's like, hey, that's 1d. We get it. D plus 20 is the exact same thing as 1d plus 20. All right. So, property of the opposite of a sum. For all real numbers a and b, if we have this negative outside of parentheses, what that means is it's just like the distributive property that it goes to each of these in there. That negative is just like a -1 outside that can be distributed. So that negative times a becomes negative a. And the negative times b becomes negative b. It becomes negative a plus b.
So even if it's just a negative, you still distribute it? Like if there's a minus sign outside the parentheses?
If there's a so imagine it if it's easier that it's a -1 out there being distributed. -1 times a is negative a. -1 times b is negative b. Still distribute it. If that were a -2, you would know to multiply -2. It's just a negative sitting there, so that's how we deal with that. So now we've got give the opposite of each expression. So think about it. When we say the opposite of each expression, here is 3y plus 5. That's where we're starting with, and we need the opposite of that. So what they're saying is, give me the opposite of each of those terms. I'm going to put that little negative right out front. This is the work when it says give the opposite that I should see there. That little negative out front. And where can I go? Let me just clear that up because that does not look very nice. Now that I have that little negative out front, what else can I do? Distribute. So negative times, let's call that a -1 times 3y. -3y. And -1 times 5. -5. So the opposite of that expression would be -3y minus 5. Each of those things has become the opposite. What I don't want to see is this. I know you can do this, and I know you're all smart enough, and I know that people are going to want to do this because they're going to be like, why do I have to show all this work? I know that you could look at this and do this. That's not an acceptable answer for that. What is acceptable is by adding in a little step like this. So instead of writing 6x minus 4, just know that we need the opposite of that. So negative 6x plus 4. Put a negative out front and now distribute it. And now you're okay. Negative times negative is positive 6x. Negative times positive is negative 4. So 6x minus 4. That's what I need to see for this. And you might be like, but why? I can do that in my head. That's so silly. Those are the questions that I always ask. I was like, why do I have to write all this down when I can just do that in my head? Because what's missing, the part that like you can't see down the road yet, is that when these get huge and ugly, and we say the opposite of an expression, and it's huge and ugly, you're still going to be doing the same thing. All right. Somebody impress me. Let's find the opposite of negative xy minus 5z. Somebody hook me up.
X, Y plus 5Z.
So what am I going to write though? Like what is my next step in writing?
Put a negative out front.
Okay, put a negative out front. These two are still inside. And now what am I going to do?
Multiply the negative by xy, and then you positive xy.
Okay,
And then same thing the other one, you have positive 5Z.
positive 5z. That's exactly what I'm looking for. Now, that first one, I don't need one in front of I don't need that positive. You wouldn't be counted against, that wouldn't work against you, but it's just xy plus 5z. All right, somebody hook me up. Because these are the questions you're going to be asked on like your next test, which is Friday, I believe. Is that what it says on Canvas? I think it's Friday.
First you put all of them in first.
Perfect. So I'm just going to rewrite that here so I've got some room to work with. Put it in parentheses. Minus 8y squared plus 3y. Oh, clean that up. 3y minus 7. And then
Just you put a subtraction on the left.
put a negative out front.
And then you distribute it to everything.
Keep going. You're killing it. Keep going.
You want to say the answer?
Yeah, I mean, just walk me through it. Yep. What is, so like you can go each term one by one.
It would be negative 4y to the fifth power
Okay.
plus 8y to the second power minus 3y plus 7.
Notice that every single term there, each one of these terms became the opposite of what it was. All negatives became positive, all positives became negatives. That would be our final answer. Nice work. Ooh. All right. Next up, the quotient a divided by b. When we say a divided by b, we have to be careful. When we write that, we can write it two ways. If we were to turn that into a fraction, for example, when I say a divided by b, just think of it as numbers, like 20 divided by 5. When we do that, the first number goes in the top part of a fraction, and the second one goes in the bottom part of a fraction. So it's very important the order in which you write them, because one of them will give you the right answer, one of them won't. Or you could write it as the first number divided by the second number. Sometimes people get those reversed. So another way that we can write these is that if we've got a divided by b, it's the same thing as a times 1 over b. And what that really means is this. Look what happens if I just see that a over there. I can break it apart into two fractions. The a was on top, it's still on top in a fraction. The b was on bottom, it's still on bottom in a fraction. So that's what this means right there, is that I can separate that into two pieces. And I'm just going to rewrite that a little slower now for those people who are like, lol, what? A was on top, it's still on top. Times b was on bottom, it's still on bottom. Those two things are exactly the same. Because if you did that multiplication right there, a times 1 is a, 1 times b is b, you would end up at that a over b. Finally, we get a divided by b. That's the exact same thing. Remember, if we wrote it as a fraction, we can break that apart into a times 1 over b. So let's take a look at some examples here. 12 divided by 4. In plain English, that really means what? Look, let's break it. Pretend that pretend you have a little brother or sister. What does that mean in plain English? Let's not talk answer. Let's talk, what does that mean? 12 divided by 4.
12, I don't know, put it in 4 groups.
Yeah, split it up into 4 groups. How many are in each group? Really what it means is how many times can 4 go into 12? If I were to take 12 and divide it into 4 groups, it's 3. How many times does 4 go into 12? It's 3. All different ways of saying the same things. Now, when I get to division here, what is like the very first thing I should do when I see a negative on top and bottom of a fraction? I see a negative on top and bottom. What can I do with that? How about this? Would you agree that this is exactly the same? Okay, I'm not trying to trick anybody. That's exactly the same, right? What is a negative divided by a negative? Positive. So when we see a fraction that has negative both top and bottom, this is guaranteed that we can do every single time. So we don't have to write it out the long way. When I see a negative over a negative, I go, oh, that's going to end up being positive. And how many times does 3 go into 18? 6 times. So that's going to give me a positive 6 right there. Now, here's where it really matters. This is where people start to slip a little bit. 15 divided by negative 3/2. So we've got 15 divided by, I'm just going to write this, negative 3/2. Now, I am taking numbers and I'm dividing by a fraction. You learned 3 letters at one point. One of your math teachers at some point told you 3 letters that you can do when you run into this situation. What are those 3 letters? What is it? KCF. Keep, change, flip. When you multiply, you can multiply straight across the top and you can multiply straight across the bottom, but that's not the rule with division. So when I do this, I am going to keep the first one the same. When I've got division, keep the first one the same. Let's just see, keep. Change the division to multiplication, and then flip the last one. Now we can multiply straight across the top and straight across the bottom. What is 2 times 15? And 1 times negative 3? All right, is that going to end up positive or negative? Negative. And how many times does 3 go into 30? 10 times. Keep, change, flip. When you divide by a fraction, every single time I'm expecting keep, change, flip. Divided by, and then you see a fraction, keep, change, flip. Every single time. All right, so here's our rules for division. The quotient of 2 positive numbers or 2 negative numbers is a positive number. That just means a negative divided by a negative is going to equal positive, or a positive divided by a positive will equal positive. Same rules in multiplication, we're just dealing with division here. The quotient of 2 numbers when one is positive and the other is negative is a negative number. Whether that looks like this, negative divided by positive equals negative, or positive divided by negative equals negative. Doesn't matter whether that negative is on top or bottom. If there's only one negative, it's going to end up negative. All right. So again, I gotta obey my order of operations here. Parentheses, exponents, multiplication, division. So I've got parentheses here, right? Lots of them. Is there anything inside the parentheses that I can do? Inside parentheses? No, but that bar works like a set of parentheses too. So let's look at the top. on top, let's start there and saying, really what that means is that the top has to be done separate from the bottom. So the top, we've got negative 9 divided by negative 3. What is a negative divided by a negative? It's a positive. And what is negative 9 divided by negative 3? How many times does 3 go into 9? 3 times. Now, I'm going to go to the bottom because that's a separate area. We've got negative 1 squared times negative 3. What has to be done first on the bottom? The exponent. So that's negative 1 to the second power. What is negative 1 times negative 1? That's a positive 1 times negative 3. And what is positive 1 times negative 3? All right. So look at that. Positive 3 divided by negative 3. Will that answer be positive or negative? Negative. And what number should I have next to it? 1. 3 over 3 is just 1. That's negative 1. And our last problem that we're going to do today has to do with splitting up fractions. Now I'm going to tell you right here, this is the one that's going to get people. If I've got A plus B, if I've got two things that are either being added or subtracted all over the same denominator, then that means the same thing as this. When we have this, let me clear this up here. It's the same thing as A over C plus B over C. You see how that's just split up there? There's two fractions actually hidden there. A over C plus B over C. Same as A minus B is the same thing as A over C minus B over C. All we're going to do is split up those fractions, so we're going to see that right here. Notice I'm going to do the same thing here. I've got the first part, which is here. Both of these things are over negative 3, so I'm going to rewrite them. I've got 48 over negative 3 minus 12x squared over negative 3. So now I actually think that's way easier to do because they're individually split up there. So let's start with the left-hand side there. We've got a positive divided by a negative. So is that going to be positive or negative, this first part here on the left? It's going to be negative. And what is 48 divided by 3? 16. Even if you weren't sure about that, that shouldn't be a calculator problem. You can actually work it out. Minus, that's way too high, minus, I've got 12x squared divided by negative 3. Is that going to end up positive or negative? This part will end up negative. And what is 12x squared divided by 3? Only the numbers can be divided, and the x squared is going to stay the same. X's divide with x's, there's no other x's to divide with. Now, only one last thing to do with this. What else can I do with this? Okay. I shouldn't have said only one last thing. We usually don't write the numbers first. We usually write the variables first, so that's exactly what I'm going to do. Notice that this is a positive 4x squared. I'm going to write 4x squared. And notice that this is a negative 16. I'm going to write that next. I'm just going to swap it around. Both of those are exactly the same. I just wrote them because if you were to see this, like if this were multiple choice, that's how that answer would be written. And it might be confusing if you didn't understand that the variables are usually written first. That is what you're going to be doing for homework today. But before we do homework, I'm going to pass out the quizzes and take any questions that we've got.